Greetings to all, welcome to the channel Simtech05. In early days, in one of my video, I talked about the method to solve dynamic problem. Those are nothing but implicit and explicit technique. We seen the application differences, we talked about the efficiency, accuracy and other points, but we not digged into any of these scheme, neither in the explicit scheme nor in the implicit scheme. But today I try to little bit dig into explicit scheme and I will try to explain you how the explicit scheme actually work behind the software. These type of advanced topic I generally covered in my Abacus advanced batches, and here you have a PDF of all the topic those I covered in advanced batch. And I also shared this PDF on my Facebook page, my Facebook group Simtech05. If you want this PDF, you can go through that. I will provide a link on the video description. So here we have, So here we have direct scheme through which we want to solve a dynamic system, and then we have these two schemes, explicit scheme and another one is implicit scheme. So we will try to understand this explicit scheme in today's class, but not through this PDF. We will go through the PPT. Okay. So if we have any dynamic system, basically we try to find out the responses of the system, how it will behave when it is subject to any initial load, any displacement or velocity. So basically, if I talk about this typical governing equation, there we have mass matrix that is known, there we have damping matrix, stiffness matrix and the applied load. These parameters are the known parameter, and this particular force, that may be initial displacement or velocity or some impact type of loading or some time dependent load. So what are the unknowns in this equation? We have unknowns u double dot, u dot and u. These are nothing but acceleration, velocity and displacement. These are the unknowns and these we want to find, and these are the actually response of the equation. Say I want to find the velocity and acceleration on this particular point at the time of 0.5 second or maybe anything else. So this is our main target behind dynamic equation, or we can say dynamic equation solution. What we want to find out the response, displacement, velocity and acceleration. But there is one problem. We cannot find these three parameters only by using this one governing equation. These are the three unknown and one equation we have, we cannot find it. But what we can do, we can make some relationship between velocity, displacement and acceleration and try to convert velocity and acceleration in terms of displacement. Then only one unknown will be in the equation and we try to solve the equation. So to make the relationship between displacement, velocity and acceleration, this central difference approach we have, this is very famous one. Of course, apart from central difference, we have forward difference and backward difference methods, but we will try to use this central difference method. I'm not going to explain this graphical approach completely in this video because the video become more lengthy. If you want to know more about this, you can follow any standard FEA book as well as you can join my advanced batches. So finally we will get the velocity in terms of displacement, and we want to find the acceleration also in terms of displacement, but directly it is not possible. So we first found the acceleration in terms of velocities, then again we converted velocities into displacement, and finally we will get acceleration also in terms of displacement. So this was our main target, velocity in terms of displacement, acceleration in terms of displacement. But look it carefully. This velocity of ith term not depend on the any ith displacement. It's depend on the ith plus 1 displacement and ith minus 1 displacement. Similarly here, you want to find the acceleration at the ith increment, but that depend on the ith plus 1, ith and ith minus 1 increment displacement. So that is problem, and of course we have solution for that. So please keep in mind these two equations, u double dot and u dot. So move to the next slide. Again this typical governing equation, and we will put u double dot and u dot value because we want to make a equation in which we have only one unknown. So we just put these values, and now in this equation, earlier the unknowns was u double dot, u dot and u, or we can say acceleration, velocity and displacement. And in this equation the unknowns are now only the displacement term, but displacement of uith, uith minus 1 and uith plus 1 term, and these are the earlier unknowns. And what we did, we just simply collect the uith plus 1 terms, uith term and uith minus 1 term, and this particular term is known as combined stiffness term, and this second term is known as combined force term. Of course this is not stiffness term, but we denote it by capital K cap, and this is the completely force term. If you consider the unit of these term, they will be give you same as a force unit, Newton. You can calculate that. Please make sure here this term we considered as a capital K cap, and this complete term we considered as a capital P cap. And here we have pith term, this one. Then this term we considered as a and this term we considered as a B for sake of simplicity. And finally we can say uith plus 1 is unknown with the K cap equal to P cap, and we can easily find this uith plus 1 displacement by inversing this K cap matrix. So of course inverse has to be take place. Okay, hope you remember this equation, velocity and acceleration. And if I want to find the initial velocity, just feed I equal to 0. So you will get the initial velocity, and similarly you will get the initial acceleration. And by help of these two equations, we can find one special term, that is u minus 1. Physically it's not possible at minus 1th increment, but it is very special term. We need this term to find out the solution. I will let you know. And again this governing equation and u double dot 0, this term we can find out using the initial condition, initial force, initial velocity or initial displacement. These initial velocity and initial displacement, these are known by boundary conditions, so we can say initial acceleration also known to us. Okay, so please remember these equations also, uith minus 1, not need to remember, but just keep in mind like we found the uith minus 1 term and u double dot 0 term. So in this slide we will understand how the explicit algorithm actually work. Okay, here we have increments, 0th increment, 1st increment and so on. The time step, yeah, of course the time step is not that much accurate for the each increment, like 1 microsecond, 2 microsecond, that may be vary. But for sake of simplicity, we are taking 1 microsecond, 2 microsecond and so on. It's depend on the element type, element size and many other parameters of the material. The P, the applied load, that is also known to us. So what is unknown? These are the unknowns. Okay. So as I told you, the u dot that is known to us by using initial boundary condition. Say I applied any initial displacement to my system. So the u dot is known to us. Or initial velocity. I applied initial velocity to the system, then this u dot is known. Okay. Now move to the next point. U double dot 0. This is also we can find by using this equation. Just in previous slide we seen this. So now we can say the all term in the 0th increment we know. We may populate the solution for the next increment using this equation. Earlier we developed this equation, and what we want to find actually for the next increment, for the first increment, I want to find the relative displacement, velocity and acceleration. So what value I have to put here to make u1? So I have to put 0. So we can say u1, let me go with the marker pen. So here, I'm sorry, pen, and so I have to put as a 0, 0, 0 and 0. So u1 now we can find. Of course, this k cap term, as we know from the previous slides, this can be given by this formula, and this p cap, hope you remember, this can be given by this formula, and here this one is the a term and this one is the b term. Okay. So the k we can find by given value of mass and stiffness matrix as well as time period, or we can say time increment, actually not time period. Now talk about this p cap. In this p cap, let's put I equal to 0, I equal to 0. So P0, do we know the P0? Yes, of course we know the P0, the load applied in the previous increment. Again, this U0, do we know? Yes, of course we know. How we know? Because earlier we found U0 by initial boundary conditions. Then this A value, this is the A value we can find very easily. And again I equal to 0, and this become uith minus 1 term. See, this uith minus 1 term is very important to populate the solution further, and we already found this uith minus 1 term in previous slide, and this is again already known to us. So all unknowns are known now. Okay, A, B are already known, P0, U0 and uith minus 1 is known. So we can say the P cap 0 is known. If the P cap 0 is known, K cap 0 is known. So here U1 can be found very easily. Now we can say, okay, this is known to me. Let me clear everything. Okay. Now we want to find the next term, that is the velocity term. So let me find. So we can give the velocity in term of displacement by using this formula, uith plus 1 displacement minus uith minus 1 divided by 2 delta t. So just put I equal to 1 because we want to find the uith velocity. So just put I equal to 1, and here also I equal to 1, and here also I equal to 1. So what will happen? This become u2 and this become u0. There is one problem. What is the problem? The u2 is still unknown to us, so we cannot find velocity, or we can say u1 dot, till we don't know the u2. u0 is known to us, but u2 is not known. So to populate the solution further, first we have to find the u2. Then only we can go to find velocity at the first increment u1 dot. So again using this formula, just put I equal to 1, because if I put I equal to 1, this become u1 plus 1 u2. u2 equal to, we feeded I equal to 1. Okay, so k1, again this is calculated for the each increment. So software can calculate what mass and damping involved in the increment. So it's not a difficult to calculate. Then again P1 we have to find. Again the P1, say P1 cap, then P1 and U1, and put again here 1. So P1 cap will be P1 minus this will be U1 A cap, not A cap, only A, minus U0 and B. So look at that. Of course, the force applied in this increment is already known to us. So P1 is known. U1 is already known. We found previously. A can be calculated using this for the second increment. Similarly, B can be calculated for the second increment, and u0 is already known to us. So everything is known. So p cap is completely known, p cap 1 is completely known. So u2 also now we can say is predictable. So if we know the u2, what will happen? The velocity term, again come to this point, this particular point. See, u2 is known to us. Again come to this particular point, u2 minus u0 divided by 2 delta t. So u2 is now known, u0 is known, divided by 2 delta t. Delta t is nothing but your time increment. Now we can say yes, the velocity for the first increment is known by help of displacement at the 0th increment and displacement at the second increment. Now let me find the acceleration also. Acceleration at the first increment. So just find u1, u double dot 1, then here put 1, here put 1, and here put 1. So this become u2 minus this become 2 of u1, and this become u of 0. 1 minus 1 become 0. So u2 is known, of course u2 is known, minus 2 u1. u1 is known, of course u1 is known from here, and u0. This u0 is also known. So we can say the u double dot 1, or we can say acceleration at the first increment is known. So in this way, the every parameter, unknown parameter in the first increment is known. Now we can say again, we can populate the solution for the further increment, and this procedure will continue throughout the analysis. So hope you got the idea how the explicit algorithm basically worked and how it tried to find the unknowns in terms of displacement only. So that's all for this video. Thank you for listening. Yeah, of course we have again beta Newmark method and so on, but we will not going to discuss this in the same video. So as I told, if you want to know more about the algorithms and dynamic analysis, you can join my batches, advanced batches. You are most welcome to join. Of course, I will upload few of the videos on YouTube also. You can take help from those videos also. One more request or announcement is there. I already started work on the FEA and Hyperlife for the fatigue simulation, and surely I have lots of to share with you, with everyone. But literally I'm looking for a fatigue expert with which I can collaborate, because you know dealing with the software is different thing, and be an expert in the fatigue. Of course I know the fatigue, but I need a collaboration with the some fatigue expert. So I request you please collaborate with me. It will be very helpful for me also, and as well as it will help to everyone, whoever following me on the YouTube, whoever watching my videos on YouTube, that will be helpful to everyone. Thank you.